Hello viewers, this is Work Ronald taking you through this tutorial for A-Level Applied Mathematics. And in this tutorial we're going to talk about the topic for velocity time graphs for linear motion. And this topic is in mechanics and suitable for students in Senior 5 and Senior 6. So velocity time graph for linear motion can be subdivided into three: one for uniform acceleration, and that will have a positive gradient as you can see it. Another one will be for uniform velocity. So the one uniform means constant, so uniform velocity means constant velocity, just as you can see it here. So it's just a horizontal line. And the third is the one for uniform deceleration or uniform retardation. For this case, the gradient is negative. So basically those are the three graphs, and they can be combined into one journey. For example, if I combine uniform acceleration, uniform velocity, and uniform retardation, I'm going to come up with a graph as shown here. So now we are going to combine the stages, and we're going to combine for a motion consisting of first uniform acceleration, then followed by uniform velocity, and lastly uniform retardation. The graph will be as shown. So those will be the axes. The horizontal is time in milliseconds, and vertical axis is velocity in meters per second. So this is first uniform acceleration. So this is now the time taken during uniform acceleration from A to B, and V is the final velocity, and this 0 is the initial velocity for motion AB. Now this S1 will be the distance traveled, and that distance is equal to the area of this triangle, or the area under the graph. Okay, so from uniform acceleration we shall go to uniform velocity. So uniform velocity is a horizontal line, so I think I can see motion BC is for uniform velocity, and T2 is the time taken while traveling with uniform velocity, and S2 will be the distance covered under uniform velocity, and this distance will be equal to the area under this rectangle. Then lastly, to be uniform retardation or uniform deceleration, which is motion CD, and this T3 is the time taken while the particle is retarding uniformly. Then S3 will be the distance traveled during uniform retardation, and it can be got by getting the area under the area of this triangle. So I think I realized that when I add T1 to T2 to T3, I'll come up with T, and this T is what we call the total time for the whole motion, for motion A, B, C, D. Okay, so like I said, total area under the graph represents the total distance traveled. For example, in this case, if I want the distance traveled by motion from A to B, I'll get the area of this triangle, which will be a half base height. In this case, our base is T1 and our height is V. So I'll come here and say that S1 will be equal to a half times T1 times V. The next will be distance traveled by while with uniform acceleration, and that is distance S2. Now this distance S2 will be the area of this rectangle, and rectangle will be length times width. So length will be T2 and width will be V. So in this case we shall come and write that S2 is equal to T2 times V. Then lastly is this S3, which is distance traveled during uniform retardation, and it will be equal to the area under this graph, which is area of the triangle. So this area of the triangle in this case will be a half BH, where T3 is the base and V is the height. So we shall come here and say that S3 is equal to a half T3 V. So from there you can get the total distance traveled from A to D by adding up all these distances. So you add S1 to S2 to S3 to come up with the total distance traveled from A to D. So alternatively, you can remember that this is a trapezium. If you look at this, shape ABCD is of a trapezium, so you can get the total distance by getting the area of this trapezium. So the area of the trapezium will be a half h, where h is v, and a is this distance, which is this from B to C, which is t2, and B will be from A to D, which is t. So we shall come here and say that the area or the distance traveled will now be equal to a half v in brackets t plus t2. Okay, so now that we have got that brief introduction, we shall go through the solution to this problem. So example 1 says, example 1 was got from UNEB 2003, paper 2, question 8, and it says a train starts from station A with a uniform acceleration of 0.2 meters per second squared for 2 minutes and attains a maximum speed and moves uniformly for 15 minutes. It's then brought to rest at a constant retardation of 5/3 meters per second squared at station B. Find the distance between A and B. I think we can see that now this one, the motions have been broken up. First was uniform acceleration. At first was uniform acceleration, followed by uniform velocity, and afterwards it will be uniform retardation. So when you are sketching the graph, we shall start with first or showing the graph for uniform acceleration. So first of all, you have to draw the axis. Horizontal axis will be for time and vertical axis will be for velocity. And after that, we shall now show the graph for uniform acceleration. So uniform acceleration was 0.2 meters per second squared, and the time taken during the uniform acceleration was 2 minutes. Okay, so these 2 minutes have to be converted to seconds by multiplying by 2 by 60 to come up with 120 seconds. Because our axis, the time is measured in seconds according to this labeling. Then now this final velocity, we don't know it yet, but so we shall call it a letter V to denote final velocity. So this is the acceleration from motion A to C. And now S1 will be the distance covered during acceleration. So next they said it attains a maximum speed, so this maximum speed will be v, and moves uniformly for 15 minutes. So that is uniform velocity. So we shall show it like that. So uniform speed is, it takes 15 minutes, so you have to convert 15 to seconds by multiplying by 60. So 15 by 60, I'll come up with 900 seconds. So this will be the time for it taken during uniform velocity, and the S2 will be now the distance traveled during uniform velocity, which is equal to the area of this rectangle. The next, lastly, they said it is brought to rest at a constant retardation of 5/3 meters per second squared. So retardation will be that, so from the maximum velocity to 0. So I think this is 0, so it's brought to rest because it was brought to rest. So this is the retardation. I think you can see that there is a negative, so that negative is to denote retardation. Then S3 will be the distance traveled during retardation, and T3 will be the time taken during retardation. So with that sketch, we shall now answer the question. So we shall start by motion SC. So this is motion SC. Remember, they want the distance between station A to B. So motion AC, we can get distance S1 by getting a area which is a half base height, but now we don't know yet the value of V, so we have to first get V using the first equation of motion, because V is equal to U plus AT. So A is 0.2, T is 120, and U is 0. So when we use that, we shall come up with our value of V to be equal to 24 meters per second. So now that we have got V, we can get the area of that rectangle, which will be a half times base, which is 120, times height, which is the value of V we have got. So when we do that, we shall come up with S1 being equal to 1440 meters. Next, we shall now go to motion CD. So motion CD is a rectangle with which will be equal to 900 times the value of V, which is 24. Okay, so when we multiply 900 by 24, we shall come up with 2,12600 meters. So I think we realize that now we use meters, not, because some students confuse it. They usually, because we use the formula for area here, they usually write the unit for area by saying meters squared, but it's not correct. So it has to be meters. You have to remember that. So now we shall go to motion dB. So for motion dB, this is dB, so it's also a triangle, but the challenge is that we don't know T3. So what we are going to do, since we know the initial velocity and the final velocity and the acceleration, we shall use the third equation of motion to come up with a distance traveled. So we shall come here and say that S3 is equal to V squared minus U squared over 2A. Now V squared was 0, because final velocity, initial velocity was 24, and acceleration was negative 5 over 3. So when we use a calculator, we shall come up with my S3 being equal to 172.8 meters. So now that I've got S1, S2, and S3, I'll simply add the 3. So I'll add S1, S2, and S3 to come up with the total distance. So we'll come here and say that distance traveled from A to B will be equal to S1, S2, and S3. When I add S1, so S1 was 1440, S2 was 21600, and S3 was 172.8. So when I add that, I'll come up with 23212.8 meters. So basically that's what they wanted, and now let's see how marks can be awarded. So first mark is for distance AB, second mark is for distance CD, and third mark is for distance DB. Then here M1 is for addition and A1 is for the output. So basically that's how the 5 marks could come about. So now we shall go to example 2. Example 2 says, example 2 was got from UNEB 2007, paper 2, questions 10, and says a car started from rest, accelerated uniformly for 2 minutes, and then maintained a speed of 150 kilometers per hour. Another car started 2 minutes later, know that word, 2 minutes later, from the same spot, and this car too accelerated uniformly for 2 minutes and then maintained a speed of 75 kilometers per hour. Part A, draw a velocity time graph and find when and where the second car overtook the first. Then part B, the first car maintained the speed of 50 kilometers per hour for 10 minutes. It then decelerated uniformly for another 2.5 minutes before coming to rest. How far has the car traveled from the start? So first we are going to convert. We have to convert from kilometers per hour to meters per second. So when I convert, for example, 50 kilometers, so kilometers to meters I have to multiply by 1,000. Then from per hour to per second I have to divide by 3,600. So when I do that, I'll come up with 50 kilometers per hour being equal to 125 over 9 meters per second. So I'm going to do the same for 75 kilometers per hour, and I'll come up with 125 over 6 meters per second. So now that I've converted, I can now come and draw my velocity time graph, where time is in seconds and velocity is in meters per second. So I'll start with the first case. The first case says that a car started from rest, accelerated uniformly for 2 minutes. So let's first draw the graph for acceleration for 2 minutes. So 2 minutes will be 120 seconds, so that's why you see here 120 seconds. And the velocity of 50 kilometers per hour is 125 over 9. That is why you see here 125 over 9. So this is the graph for uniform acceleration. After that, they say that the car then maintained a speed of 50 kilometers per hour. So here that means that it is going to move with constant speed. So that is a graph for constant velocity. So it will move with a constant speed up to point C. So this is the graph for the first car. What about the second car? For the second car, it says that another car started 2 minutes later from the same spot, and this car too accelerated uniformly for 2 minutes. So it started 2 minutes later. So remember, these are the 2 minutes, so it is going to start from this point. So the car is going to start from that point. So let's draw the graph. So that will be the graph for the second car. It also accelerates uniformly for 2 minutes. That is why you see here 120 seconds. So it attains a speed of 75 kilometers per hour, which was converted to 25 over 6. That is why you see here 25 over 6 as our final speed. Then from there, they say that the car then maintained a speed of 75 kilometers per hour. So that means that from there, from this point to where it is going to maintain a speed of 75 kilometers per hour, which is 125 over 6 meters per second. So this is the motion for second car, and this is the motion for the first car. So that is part A, because part A they said draw a velocity time graph and find when and where the second car overtook the first. So we have to find when and where, but before we go to the next slide, let's first see the marks for this slide. So B1 is for conversion, so converting both to meters per second, that's B1. Then another B1 is for the first car, another B1 is for the second car, motion of the second car. So basically that's how the 3 marks could be got. And now let's see how we can get when and where they met. So when they meet, since they started from the same point, it means that the distance traveled will be the same. So what we are going to do, we shall go back to this graph and look for distance AB. So distance ABC, realize that it's a trapezium. This is the trapezium with the height of 125 over 9. Then A is 120 plus T, and this, and B is 120 plus 120 plus T. So when we do that, we shall come up with our distance moved by from A to B to C as a half times 125 over 9, which is the height, and then multiplied by, in brackets, 124. Now this 124 is the 120 plus 120, 240 is the 120 plus 120 to come up with the 240, then plus C, which is this. So this distance from here to here is 240 plus T. Then this 120 plus T is this distance. from here up to here will be 120 plus t. So that with that we shall be able to get the area of a trapezium, which will be the distance traveled. So distance traveled from A to B to C will be 125 over 18 multiplied by 360 plus 2t. Now next we shall go to distance traveled by second car, which is xyz. So when you look at this xyz, from here to here to here is also a trapezium with height of 125 over 6. Then A is t and B is 120 plus t. So you shall come here and say that the distance will be half times 125 over 6 multiplied by open brackets 120 plus t, which is this 120 plus t, then plus this t to come up with that. So when I use a calculator, I'll come up with 125 over 12 in brackets 120 plus 2t. So I've got the two distances, total distance traveled by both cars. This is the distance ABC is the distance traveled by car A, and distance XYZ is the distance traveled by car B. Therefore, remember both cars will cover the same distance. That means that this distance will be equal to this. So therefore, when I substitute, I'll equate this, so this will be equated to this, as you can see it here. And I'll have to simplify because I have only one unknown, which is t. So I'll have to simplify and make t the subject. So when I do that, I'll come up with t being equal to 180 seconds. So now before we go to the next slide, let's see how marks can be awarded for this slide. So B1 is for you to get distance ABC, B1 is to get distance XYZ, and M1 is for equating the two. B1 is to simplify, and B1 is to get the total time taken, which is T. Time taken for this, for getting the value of T, which is this. So this is the value of T which you have now got. So now that we know the value of t, we shall come back to this equation from this xyz to substitute t here, and I'll be able to get my distance xyz as 5,000 meters. Therefore, the second car overtook the first car at a spot 5,000 meters or 5 kilometers from the starting point, and it took him 300 seconds to travel. So the road time taken was 300 and the distance traveled was 5,000 meters. So the 5,000 meters is this distance. So from here up to here, so they meet at this point. So ABC, this is the point where they meet, and this one will have moved distance XYZ. So now that we have got that, we can now go to part B. So part B says the first car maintained the speed of 50 kilometers per hour for 10 minutes. It then decelerated uniformly to another 2.5 minutes before coming to rest. How far has the car traveled from the start? So here shows that total distance from start will be equal to 1/2 times 125 over 9, then multiply by 120 plus 600 plus 150, then plus 600 to come up with, this is the area of a trapezium, to come up with our total distance being equal to 10208.333 meters. Okay, so now let's see how marks can be awarded for this part. So M1 is for you to substitute, and A1 is for the output. M1 is for you to substitute, and A1 is for the output. So basically that's how you could get the 12 marks in this example. Okay, so that brings us the end of this lesson. Thank you for watching, and be reminded that the next video will be on vertical motion and gravity. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video for motion, vertical motion and gravity has been uploaded. Otherwise, thank you for watching, and and if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.